Good morning to all of you. Rahul Jha welcomes you. Today we are going to talk on green hydrogen, which is today's most wanted fuel. We'll also talk about why it is important to use this fuel and why this fuel has become very important, and what are good points and bad points in using this fuel. So let's start. Today the most important point is that what is best energy source. So if we really see, choice of best energy source depends on various factors including geographic location, energy demand, environmental conditions, economic factors, and different energy sources have their advantages and disadvantages. Here are some commonly used energy sources. Fossil fuel, that is coal, oil, natural gas. Historically, they have been the primary source of energy, but they continue to contribute air pollution and greenhouse gas emissions, leading to climate change. Next is renewable energy. These are solar power, which is harnessed from the sun using photovoltaic cell. Wind power. This uses kinetic energy of wind to generate electricity. Hydropower. This is generated from movement of water, often through dams. Geothermal energy. This is tapped from the Earth's internal heat for power generation. Biomass. This uses organic material for energy such as wood or agricultural waste. Nuclear power. This generates electricity through nuclear reactions. While it produces a large amount of energy with low carbon emission, concerns about safety, radioactive wastes and nuclear proliferation exists. We have already seen there were some accidents in Russia and which caused big damage to all which of the people who are residing in nearby countries also. The best energy source depends on the specific requirement and constraints of a given situation. Increasingly, there are global push towards renewable energy sources due to their low environmental impact and need to mitigate climate change. However, challenges such as intermittency in case of solar and wind power and energy storage still needs to be addressed. So we will have to consider the latest and recent data for assessing the current best energy source. Now the most sought after energy source today is wind energy. So what is wind energy and how electricity is produced from it? Wind energy is renewable energy source that harness the kinetic energy of moving air, converting it to electricity. The process involves using wind turbines to capture the energy of wind and convert it into usable form of power. Here is a step-by-step explanation of how electricity is produced from wind energy. Wind energy production needs wind turbines. Wind turbines are the primary technology used to generate electricity from wind energy. These turbines consist of large blades connected to a hub. The hub is mounted on a tall tower to capture the higher and more consistent wind speed at elevated heights. Wind capture. When the wind blows, it causes the turbine blades to rotate. The design of blades is such that they capture the kinetic energy of the wind. Rotor and generator. As the turbine blades spin, they turn a rotor connected to a generator. The generator is the component that transforms mechanical energy into electrical energy. Electromagnetic gun induction. Inside the generator, there are coils of wire and magnetic field. The rotation of the rotor within the magnetic field induces a flow of electrons in the wire through a process called electromagnetic induction. Electricity generation. The flow of electrons creates an electric current which is used then to generate electricity. The electricity generated by single wind turbine is typically in the form of alternating current. Power grid connection. Electricity generated by individual wind turbines is often connected to a power grid. Multiple winds can be connected to a grid, creating a wind farm. The power grid then distributes the electricity to homes, businesses, and other consumers. It is important to note that wind energy is intermittent, meaning it depends on wind speed. Wind turbines are most efficient when placed in area with consistent and strong winds. Additionally, advancement of technology such as energy storage systems are being explored to address the intermittency of wind energy and provide a more reliable and consistent power supply. So what is renewable energy? Renewable energy refers to energy that is collected from the source that are naturally replenished on a human time scale. These sources are virtually inexhaustible over the long term and do not deplete when used. Unlike finite fossil fuels, renewable energy source can be sustained indefinitely. Here are some common types of renewable energy source. Solar energy. This is harnessed from the sun using photovoltaic cell to generate electricity or through solar thermal system to produce heat. Wind energy. This is captured when kinetic energy of wind using the wind turbine to generate electricity. Hydropower. This converts energy of flowing or falling water into electricity, typically through the use of dams or water turbines. Geothermal energy taps into the Earth's internal heat produced steam, which is used to generate electricity or provide direct heating. Biomass. This uses organic materials such as wood, agriculture, crops and wastes to produce heat, electricity or biofuels. Renewable energy is considered environmental friendly because it produces little or no greenhouse gas emissions or air pollutants during operation. As a result, it plays a crucial role in mitigating climate change and reducing dependence on finite and environmentally harmful fossil fuel. Advantages of renewable energy includes sustainability. That is, renewable sources are naturally replenished and can be sustained over long term. Reduced environmental impact. Compared to fossil fuel, renewable energy sources generally have lower environmental impacts in terms of air and water pollution and greenhouse gas emissions. Energy security. Diversifying the energy mix with renewable energy can enhance energy security by reducing dependence on imported fossil fuel. Job creation. The renewable energy sector often generates employment opportunity contributing to economic development. Despite these benefits, challenges exist such as intermittency in certain renewable sources such as solar and wind, and the need for energy storage and improved grid infrastructure. Ongoing advancement in technology and increased adoption of renewable energy are essential for creating a more sustainable and resilient energy future. Now we'll be talking on hydrogen fuels. Why they have become very important today. As we know that hydrogen is abundant and you can find hydrogen anywhere. So let's talk about things about hydrogen. How many types of hydrogen is there? So hydrogen exists in different isotopic forms, meaning it has variation based on number of neutrons in its nucleus. The three primary isotopes of hydrogen are protium. This is most commonly the abundant form of hydrogen, making up of about 99.9985% of naturally occurring hydrogen. It consists of single proton and no neutron. Deuterium. Deuterium is a stable isotope of hydrogen, meaning it does not undergo radioactive decay. It contains one proton and one neutron on its nucleus. It is also denoted by D, 2H or D. Deuterium is found in small amount in naturally occurring hydrogen, making up about 0.015%. Tritium, which is 3 hydrogen or 3H or sometimes denoted by T. Tritium is a radioactive isotope of hydrogen. It is relatively rare in nature. It contains one proton and 2 neutrons in its nucleus. Tritium decays over time, transforming into helium-3. Tritium is produced artificially for various purposes, including in some type of nuclear reactors. From the industrial energy perspective, hydrogen is often categorized into different colors based on how it is produced. Most important type of hydrogen that is being used today is grey hydrogen. This is produced by natural gas through a process called steam methane reforming, that is SMR. This process releases carbon dioxide as a byproduct. Second is blue hydrogen. This also produced from natural gas, but the carbon dioxide emissions are captured and stored, preventing them from entering the atmosphere. This process is known as carbon capture and storage, that is CCS. Green hydrogen. This is produced using renewable energy sources such as solar, wind or hydropower through a process called electrolysis, where water is split into hydrogen and oxygen. Green hydrogen is considered environmentally friendly as it does not produce carbon emissions during production. Turquoise hydrogen. This is produced from methane, but the process captures and utilizes the resulting solid carbon rather than releasing it into the atmosphere. These color distinctions are important in discussions about the environmental impact and sustainability of hydrogen production methods. Each type of hydrogen has different applications and implications for addressing climate change and achieving a more sustainable energy system. Now we'll talk about what is green hydrogen and how it is produced. Green hydrogen is hydrogen produced using renewable energy source such as solar, wind or hydropower in a process known as electrolysis. Unlike traditional method of hydrogen production that rely on fossil fuels, green hydrogen is considered environmentally friendly because it does not produce carbon dioxide emissions during its production. The production of green hydrogen involves the following steps. Electrolysis. This is the key process of green hydrogen production. Electrolysis uses electric current to split water, H2O, into two constituent elements, hydrogen and oxygen. The basic reaction is H2O, which splits into H2 and O2 plus electricity. Now, for breaking this water, electricity is used and water breaks into H2 and O2. Now this hydrogen is produced from a renewable source and overall production of carbon is zero. So we call it green hydrogen, as there is no carbon produced during production of this hydrogen. Now, renewable energy source. Electricity needed for electrolysis comes from renewable source such as solar, wind or hydropower. These sources provide a sustainable and clean energy input, making the entire process environmentally friendly. As we know that it is very easy to find these type of energy, that is solar, wind and hydropower, which exist almost everywhere. Though hydropower has some limitation, but solar and wind power can be used in almost every place on this earth. So these sources provide a sustainable and clean energy input, making the entire process environmentally friendly. Now, electrolysis technology. Proton exchange membrane or PM electrolysis. In PM electrolysis, a membrane selectively allows protons to pass through while blocking the passage of electron. This type of electrolysis is suitable for small scale applications and can respond quickly to changes in electrical input. Alkaline electrolysis. Alkaline electrolysis uses a liquid alkaline electrolyte to facilitate the movement of ions. It has been used for large-scale application and has a longer operation life compared to PM electrolysis. Solid oxide electrolysis cell. SOEC creates a high temperature and can directly use high temperature heat, making it suitable for integrated systems that combine electrolysis with other industrial process. Hydrogen compression and storage. Once produced, the hydrogen gas may undergo compression for storage and transportation. Now, hydrogen can be stored in various forms such as compressed gas or liquid hydrogen. Green hydrogen has gained attention as a potential clean energy carrier because it can be used in various sectors, including industry, transportation, and power generation, without contributing to greenhouse gas emissions during its productions. However, challenges such as cost of renewable energy and electrolysis technology needs to be addressed for widespread adoption. Advances in technology and increased investment are expected to contribute to the growth of green hydrogen in the global energy world, that is global energy landscape. Now, today we are hearing about green hydrogen, and almost everywhere, go anywhere, either in economic world or in stock market, everywhere we are seeing people talking about green hydrogen. So why green hydrogen has become so important? So today we'll be bringing out some good points on this topic. Green hydrogen has gained significant importance in today's energy landscape for several reasons. Decarbonization goals. Many countries and regions are committed to reducing greenhouse gases and greenhouse gas emissions to mitigate climate change. Green hydrogen produced using renewable energy is a clean and sustainable alternative to traditional hydrogen production methods that often involve fossil fuel and result in carbon emissions. Versatile applications. Hydrogen has diverse applications across various sectors, including industry, transportation, and power generation. Green hydrogen can replace conventional hydrogen in these applications, offering a low carbon or low carbon free alternative. Industrial process. Hydrogen is a key feedstock for various industrial processes such as production of ammonia and refining of metals. Green hydrogen can help decarbonize these industries, contributing to the goals of reducing carbon emissions and hard to abate sectors. Energy storage. Hydrogen can serve as a form of energy storage, allowing for the integration of renewable energy sources like solar and wind into the electricity grid. Excess electricity generated during the time of high renewable energy production can be used to produce hydrogen through electrolysis, and hydrogen can be stored for use later. Transportation. Green hydrogen is a promising fuel for zero-emission vehicles, particularly in heavy-duty transportation in sectors like trucks, buses, and trains. It can also be used in fuel cell electric vehicles, FCEVs, providing longer drive range compared to battery electric vehicles, that is BEVs. Grid balance. Hydrogen produced from renewable source can contribute to grid stability by providing a means of storing excess energy and releasing it when needed. This is particularly important as the share of intermittent renewable energy source such as wind and solar increases the energy mix. International cooperation. Green hydrogen has become a focal point of international cooperation and partnership. Many countries and organizations are investing in research and development and large-scale projects to promote the production and use of green hydrogen as a global traded commodity. Technology advancements. Ongoing advancements in electrolysis technology, renewable energy source, and hydrogen storage methods are making green hydrogen more cost competitive and viable for widespread adoption. While the potential benefits of green hydrogen are substantial, challenges remain, including the cost of production, infrastructure development, and ensuring a stable and sustainable supply chain. As technology advances and economies of scales are achieved, green hydrogen is expected to play a crucial role in transition to a more sustainable and low carbon energy future. Now, what are uses of green hydrogen? Green hydrogen has a variety of potential use across different sectors, driven by its environmentally friendly production process using renewable energy. Some key applications and uses of green hydrogen include industry, that is ammonia production. Hydrogen is a crucial feedstock for the production of ammonia, which is used extensively in fertilizer manufacturing. Refining. Hydrogen is used in refining processes to remove impurities from crude oils and produce cleaner fuels. Transportation. Fuel cell vehicles, FCVs. Green hydrogen can be used in fuel cell vehicles, providing a clean and efficient alternative to traditional internal combustion engine. FCVs emit only water vapor and heat during operation, and so can be considered very good. Heavy duty transport. Green hydrogen can be used in heavy duty transport modes such as trucks, buses, and trains, where the high energy density of hydrogen and rapid refueling can be advantageous. Power generation. Electricity production. Green hydrogen can be used in gas turbines or fuel cells to generate electricity. This can be particularly valuable for grid balancing and providing power during periods of high demand. Residential and commercial heating. Hydrogen as heating fuel. Green hydrogen can be used for residential and commercial heating applications, either directly or in combination with natural gas in existing infrastructure. Energy storage. Seasonal storage. Hydrogen can be used as a form of seasonal energy storage. Excess renewable energy, particularly from intermittent sources like solar and wind, can be used to produce hydrogen during times of surplus, and hydrogen can be stored for later use. Chemical industry. Hydrogen as a reducing agent. Hydrogen is used as reducing agent in various chemical processes, contributing to production of chemicals and materials. Grid balance. Grid support. Hydrogen can play a role in grid stability by acting as a form of energy storage. Excess electricity from renewable sources can be used for electrolysis to produce hydrogen, which then can be stored and used when electricity demand is high. Hydrogen-based synthetic fuels. Synthetic fuel production. Green hydrogen can be used in production of synthetic fuels such as synthetic methane or synthetic liquid fuels, which can serve as alternative to traditional fuel cells or fossil fuels. Remote or off-grid application. Remote power generation. In areas where traditional power infrastructure is lacking, green hydrogen can be used for off-grid power generation, providing a clean and reliable energy sources. Versatility of, I repeat, The versatility of green hydrogen across different sectors make it a key player in transition towards more sustainable and low carbon energy system. However, challenges such as cost, infrastructure development, and technology advancement still needs to be addressed to realize the full potential of green hydrogen across these applications. Now we'll talk about some good points that is associated with green hydrogen. The use of green hydrogen offers several advantages and benefits, making it an attractive and environmentally friendly option in various applications. Here are some key points in favor of using green hydrogen. First of all, carbon-free production, environmental sustainability. Green hydrogen is produced through electrolysis powered by renewable energy source, ensuring a carbon-free and environmentally sustainable production process. It helps reduce greenhouse gas emissions and mitigate climate change. Versatility, wide range of applications. Green hydrogen can be used in various sectors including industry, transportation, power generation, and heating. Its versatility makes it valuable resource for addressing energy needs in different areas of economy. Decarbonization of hard to abate sectors. Industrial decarbonization. Green hydrogen can play a crucial role in decarbonizing industry that are challenging to transition to low carbon alternatives such as steel and chemical manufacturing. Energy storage and grid balancing. Seasonal energy storage. Hydrogen can be used as a form of seasonal energy storage, helping address the intermittency of renewable energy source and providing grid stability. Energy security and diversification, job creation and economic opportunity. Job growth. The development and deployment of green hydrogen technologies can lead to job creation in various sectors, contributing to economic development and growth of new industry. International cooperation. Just in few days back, we have seen that G20 summit was held, and in which a burning topic was climate change. It was decided by all countries that they will go forward towards production of green hydrogen in a big way so as to tackle this climate change effect. By using this method, there will be very low carbon dioxide production, and in fact lakhs of tons of carbon dioxide will not go to atmosphere due to use of this green hydrogen, and so pollution will decrease in a big way. Thus, production of green hydrogen can see that our air is clean and people become more healthier. Long-term sustainability. Inexhaustible resource. Hydrogen is an abundant element, and its use as an energy carrier does not deplete the resource. With renewable energy source powering its production, green hydrogen offers a sustainable and long-term solution. Technology advancement and cost reduction. Innovation and cost competitiveness. Ongoing advancement in electrolysis technologies, renewable energy source, and hydrogen storage methods are expected to drive down costs, making green hydrogen more competitive over time. While there are clear benefits to use green hydrogen, challenges such as cost, infrastructure and development, and technology advancement need to be addressed to unlock its full potential and facilitate widespread adoption. There are also some bad points associated with green hydrogen. Now we'll talk about that. While green hydrogen offers numerous benefits, there are also challenges and concerns associated with its production and use. Here are some of the potential drawbacks or challenges often discussed in the context of green hydrogen. First is cost. High initial cost. The production of greenhouse gases is reduced, but production of green hydrogen through electrolysis can currently be more expensive than traditional methods, particularly those using fossil fuels. The cost of renewable energy and electrolysis technology needs to decrease for green hydrogen to be cost competitive on large scale. Efficiency. Energy losses. Electrolysis involves energy losses during the conversion of electricity into hydrogen. These losses can impact the overall efficiency of process, especially when considering the entire supply chain, inducing renewable energy generation. Infrastructure. Limited infrastructure. The infrastructure for green hydrogen production, storage and transportation is not as developed as that for traditional fossil fuels. Expanding this infrastructure requires significant investment and planning. Intermittency. Renewable energy variability. The intermittency of renewable energy source such as wind and solar can affect the availability of electricity for electrolysis. Energy storage solutions are necessary to address this intermittency. Scale-up challenges. Scaling production. Scaling up green hydrogen production to meet large-scale demand is a challenge. Significant investments are required for construction of electrolysis facility and renewable energy projects. Storage and transportation. Hydrogen storage challenges. Storing and transporting hydrogen can be challenging due to its low energy density and its tendency to escape through material. Technology for safe and efficient storage and transport need further development. Competing land use. Land use for renewable energy. The large-scale deployment of renewable energy source for green hydrogen production may compete with other land uses such as agriculture or conservation. Water usage. Water intensity. Electrolysis process require water, and in regions facing water scarcity, the water intensity of green hydrogen production can be a concern. However, the technology is being developed for more water efficient electrolysis. Global supply chain concerns. Dependency on imports. Some regions may depend on import of green hydrogen due to limitation in local production capacity. This dependency can raise questions about resilience and security of hydrogen supply chain. Transition period. Transition challenges. Transition from existing energy system to widespread adoption of green hydrogen will involve challenges and complexities, including policy adjustments, regulatory framework, and society acceptance. It is important to note that many of these challenges are subject to ongoing research, technological advancement, and policy developments. Over time, addressing these challenges could contribute to increased viability and adoption of green hydrogen as a sustainable energy carrier. Now, hydrogen fuel can be dangerous also. So, why hydrogen fuel can be dangerous? There are some points associated with this also. Hydrogen as fuel is often considered potentially dangerous due to certain characteristics associated with its use and handling. Some reasons why hydrogen fuel is sometimes called as a dangerous fuel include flammability, highly flammable. Hydrogen is a highly flammable and has a wide flammability range in the air. It can ignite easily, even in relatively low concentrations, and the flame production this is produced is nearly invisible, making it difficult to detect. Explosive potential, explosive mixture. Hydrogen can form explosive mixture with air in a wide concentration range, that is 4 to 75%. In the presence of ignition source, a hydrogen air mixture can explode if it falls within this flammable range. Leakage concerns. Small molecular size. Hydrogen molecules are small, and this allows hydrogen to leak more readily than some other gases. Leaks can increase the risk of flammability and pose challenges for safe storage and transportation. Storage challenges. High pressure or low temperature storage. To achieve practical energy density, hydrogen is often stored under high pressure or at very low temperature. These storage conditions can pose safety challenges, and there is risk of system failure leading to release of hydrogen. Material compatibility. Hydrogen embrittlement. Hydrogen can cause embrittlement in certain materials, potentially leading to structural weakness in equipment and infrastructure used for hydrogen storage and transportation. Ignition sources. Readily ignited. Hydrogen can ignite with relatively low energy inputs such as spark or heat, and this makes it important to implement stringent safety measures to prevent accidental ignition. Limited sensory detection. Odorless and colorless flame. Hydrogen flames are nearly invisible and do not produce smoke or a distinct odor. This lack of sensory cues can make it challenging to detect a hydrogen fire quickly. Human or safety concern. Now, while hydrogen itself is not toxic, high concentration can displace oxygen in air, leading to problem in breathing, and this is particularly relevant in enclosed spaces. It is important to note that while hydrogen does have safety concern, extensive research and engineering efforts are being undertaken to develop and implement safety measures to mitigate these risks. Industry standards, regulations, and guidelines are established to ensure the safe production, storage, transportation, and use of hydrogen. When handled and managed appropriately, hydrogen can be used safely as a fuel, and its potential benefits in terms of clean energy and decarbonization make it a subject of ongoing exploration and development. Now, a big point is how hydrogen can be stored and transported. Now, storing and transporting hydrogen efficiently and safely are critical aspects of integration into various energy systems. Several methods are being explored and implemented for storage and transportation of green hydrogen. Compressed hydrogen. Hydrogen can be compressed at high pressure, typically around 350 to 700 bar, and stored in high pressure tanks. The compressed hydrogen is released when needed. Transport. Compressed hydrogen can be transported using high pressure turbines or high pressure tubes or pipelines. For longer distance, it may be located onto specially designed hydrogen trailers or containers. Liquid hydrogen. Storage. Hydrogen can be liquefied at very low temperature around 253 degree or minus 423 degree Fahrenheit and stored in cryogenic tanks. Liquid hydrogen has a higher energy density than gaseous hydrogen. Transport. Liquid hydrogen is transported into cryogenic tankers or containers designed to maintain extremely low temperatures. Metal hydride storage. Metal hydrates are material that can absorb and release hydrogen gas when needed. Hydrogen can be stored within the metal lattice of these materials and released when needed. Transport. The hydrogen located at various places can be loaded and transported using metal hydrides, and then using heat or other methods the hydrogen can be released when required. Chemical hydride storage. Hydrogen can be chemically bond with certain materials, that is chemical hydrides, to form hydride compounds. Hydrogen can be released by applying heat or through a chemical process. Transport. Hydrogen can be stored in form of chemical hydrides and transported. Pipeline transport. In some cases, hydrogen can be transported through dedicated pipelines. However, these requirement requires specialized infrastructure due to unique properties of hydrogen, such as smaller molecular size, which can lead to leakage concerns. Ammonia is hydrogen carrier. Storage. Hydrogen can be combined with nitrogen to form ammonia. Ammonia is a liquid at room temperature and can be stored under moderate pressure. Transport. Ammonia can be transported using existing infrastructure and technologies for the ammonia industry. At the destination, hydrogen can be extracted from ammonia through a process called cracking. The choice of storage and transport method depends on factors such as scale of operation, distance of transport, safety consideration, and specific requirement of end-use application. Each method has its advantages and challenges, and ongoing research and development aim to improve the efficiency, safety, and cost effectiveness of the storage and transportation technologies for green hydrogen. Now we'll talk about how hydrogen is being used in India, or hydrogen in Indian context. Green hydrogen production has gained very prominence, and due to this, industry attached with this green hydrogen have also flourished. We have seen in last year that green hydrogen has got a big prominence, and due to this, wind energy, solar energy, and hydroelectric energy has come into big focus. Now, market for wind energy and solar energy has increased substantially, The company which are producing this wind energy and solar energy has grown many folds due to this concept of green hydrogen. As hydrogen is produced using wind energy and solar energy, so we are seeing that companies which are associated with wind energy and solar energy are gaining much prominence, and future lies with them. People say that companies of these nature, that is which are associated with wind energy and solar energy, will grow many times in next 5 to 10 years. We have already seen the stocks of some of these companies have become 4 to 5 times, and in some cases more, due to concept of green hydrogen. Now this green hydrogen will be manufactured in India by big companies and big names such as Reliance and Adani Group, and in public sector IOC. Now, point to be noted that first green hydrogen plant was in Duliajan, Assam, where hydrogen was successfully produced, and they have started production, and IOC company is involved in this. Other names are also very prominent and are coming to focus, and companies like Reliance and Adani Group have got a big plans for future, and they want to become world's top producer of hydrogen in future. They are working for that, and we are sure that they will become top hydrogen producers one day. India has also got big plans for producing hydrogen and exporting this hydrogen. We have already seen that there is a pact with Singapore where hydrogen will be transported, which will be produced at Andaman and Nicobar Islands, and through pipeline there are possibility of sending this electricity or even green hydrogen to Singapore. Even we have heard about news that some West Asian countries like UAE and Saudi Arabia are planning to import hydrogen from India. That is, India will export hydrogen to these countries, and there is possibility that they can produce and export this. This will be done through pipeline under the sea. So this can happen in future, who knows. So use of hydrogen fuel has also gained prominence, and we have already seen that car using hydrogen fuel is running on Indian roads now, and even companies such as Tata, they are producing hydrogen fueled buses and trucks. Companies which are in process of producing hydrogen or associated with hydrogen have also got prominence, and big names such as Tata Motors and other companies have got great plans for using green hydrogen for their vehicles. Now, Indian government is also focusing on trains using hydrogen. Now, one experiment was done few months back where a hydrogen train was run between Kalka and Shimla. Though due to very tough way, height was too much and load on engine was so much that trip could not complete, and so that project was not successful. But this was due to the fact that the way was very tough and engine could not produce so much power, and that project could not be very successful. But now, if these type of trains are run on ground or places where there is no height involved, that is on plain surface, then certainly it is going to be a success. Already there are talks of running trains connecting various cities with hydrogen trains, and if these are successful, we will see train run on hydrogen fuel, which will produce very less or no pollution, and air will be cleaner than before. There are big plans after G20 summits to increase the level of production of green hydrogen, and for that various steps are being taken to increase wind energy production, solar energy production, and a big thrust has been given in these areas. So if wind energy production and solar energy production is increased, definitely it will help green hydrogen production. We already have good and big companies which are producing wind energy and solar energy, and certainly in future these companies have got very good scope, and there will be a lot of work for these companies. As today we see that not even 10 or 20% of wind energy is being used for green hydrogen production, but in future this will become very significant, and wind energy especially will be in focus, and certainly company related to this wind energy will do so well that they will multiply shareholders' wealth by 10 times or even 20 times. So there is good opportunity for people also to know about green hydrogen and invest in green hydrogen concept. For this, investment in wind energy sector, solar power sector is very beneficial. So we have seen that green hydrogen has become very significant, and in next say 10 to 20 years production of this green hydrogen will multiply many times, and all countries will try to produce as much as possible, or they will export this green hydrogen from other countries in order to slow down pollution in air, and we'll be able to see a world which is pollution free or with very less population. So this was all today. Thank you.